All right, in this video, we're going to talk about combining two functions. And the first way we're going to combine them is just with algebraic operations. So if you are given a function, let's say f of x and g of x, you can get a new function with the name f plus g of x. And the way you'll get the new function is you'll take the old function f of x and you'll add to it the old function g of x. So we're getting new things from old things. We could also get a new function with the name f minus g of x. And we get that new function by taking f of x and subtracting g of x. We could get a new function called f times g. And you could put a dot in there if you like. I prefer not to. So f times g of x, that new function, can be found by taking the f of x function and timesing it by the g of x function. And then we could divide our function. So we get a new function with the name f over g of x. And we get that function by taking the f of x function and dividing it by the g of x function. And we have to make sure that g of x is not 0, because remember, you can't have a bottom equal to 0. So the algebra of the functions matches the name, right? If the name is f plus g, then we get that by plussing f and g. If the name is f minus g, then we get that by minusing f minus g. If the operation is f times g, then we get that by timesing. And if the operation is divide, then we get that by dividing. So the algebra of functions goes kind of straightforward. So now in this first question here, we'll call this question 1. We're going to find, we're going to have the functions g and h, and our g of x function is 2x plus 2, and our h of x function is x plus 4. So if we want the new function g minus h of x, then that's going to be the g of x function subtract the h of x function. So let's plug that in. G of x is 2x plus 2, and h of x is x plus 4. Now, I'm going to wrap both of these up in parentheses because the g of x function is the entire thing, 2x plus 2, and the h of x function is the entire thing, x plus 4. So now, the first set of parentheses don't actually matter, right? Because there's no operation out here. If there was 5 times g of x, then we would times the 5n, but there's not. So we'll keep 2x plus 2. But now subtraction has to distribute to both parts. So I've got minus x and then minus 4. Now I can combine some like terms. 2x minus x is just 1x. And positive 2 minus 4 is negative 2. So my new function with the name g minus h of x, which is found by subtracting h from g, is going to spit out a result x minus 2. Now let's try g plus h of x. So that's going to take the g function, and it's going to add to it the h function. So my g function was 2x plus 2 plus, and then my h function is x plus 4. Now again, you can think of these guys wrapped up all together because sometimes you might have numbers times on them, or subtraction, which you have to distribute. In addition, it's not really that exciting, so we're going to do 2x plus x, so that makes 3x, and then 2 plus 4 makes 6. So this new function with the name g plus h of x is going to follow the pattern 3x plus 6. Now, in this last one, g times h of -2. So remember, this is function notation. Of -2 means replace x with -2. So instead of having g of x times h of x, I'm going to have g of -2 times h of -2. So now, what is g of -2? Again, maybe you could do this. Maybe you need a refresher. So g of -2 means in the function called g, replace all your x's with -2. So I've got 2 times -2 plus 2. So that makes -4 plus 2, which is -2. That's a coincidence. So this guy is -2. Now we also need to do h of -2. So h of -2 is going to be the h function with all of the x's replaced with -2. So instead of x plus 4, I have -2 plus 4, which is +2. Again, a coincidence that there's so many 2's here. So this guy is 2. So now, what is g of -2 times h of -2? Well, that's going to be -2 times +2, which equals -4. And what that means is if I graphed the function named g times h of x, the location with x equal -2 and y equal -4 would be on the picture. So now let's talk about making this just a little bit more advanced here. We have these functions 5x minus 1, and the other function g of x is square root of x minus 4. Now we want to find both f times g and f minus g, and then their domains in interval notation. So first, let's talk about the domains. So for domain, sorry about that. For domain, there's 3 rules, but I think right now we only know 2 of them. So the rules are if you've got a rational function, then the bottom cannot equal 0. So your domain would be everything except the x values that make the bottom 0. And if you have a radical function, we have to have the inside greater than or equal to 0. So for this first function, f of x, 5x minus 1, there's no bottom and there's no radical. So the domain of this guy is all real numbers. Now for g, we've got a radical. So for the g of x function, we need x minus 4 to be bigger than or equal to 0, because you can only take the radical or the square root of a positive number or 0. So this says x has to be bigger than or equal to positive 4. So the domain for this one is 4 to infinity. So we're going to keep those 2 domains in mind when we make up our new functions. And our new functions domains will be the intersection of those 2 domains. And then if you've got something on bottom, you have to then make that restriction in addition. Okay, so let's find f times g of x. So my f function is 5x minus 1, and my g function is square root of x minus 4. Now I can't actually combine anything. Like in the last problem we had like terms. This is timesing. So I need to make sure that I've wrapped up my 5x minus 1. The x minus 4 is wrapped up underneath the radical, so it doesn't need parentheses. And this is it. This is my function. Now let's note that if you put in 5x minus 1 radical x minus 4 is wrong. And I want you to think about why it's wrong. Right? Compare what I've written in the note to what the correct answer is. And you'll see that in the note here, only -1 is times the radical. We need the whole thing times the radical. Now, okay, there's no fractions in this. So the domain for this guy is going to be all real numbers intersect 4 to infinity. So we're taking the domains of both of them and finding what's in common. So now again, it may be clear to you what is in common. It may not. So the first domain, minus infinity to infinity, is all the numbers ever. And then 4 to infinity starts at 4 and goes to the right. So the intersection is what they have in common, which is all of this stuff over here. So the domain is starting at 4 and going to infinity. Now, this is going to be the case for the next one as well. So if we want the function f minus g of x, we're going to take the f function, which remember we're wrapping it up, 5x minus 1, subtract square root of x minus 4. Now the x minus 4 is wrapped up in the radical, so you don't have to put extra parentheses. You can if you'd like to, like this is fine, but generally we wouldn't wrap that up. So now here, since 5x minus 1 is not being times by anything on the outside, those parentheses are technically extraneous as well. So I'll just write this as 5x minus 1 minus radical x minus 4. And if you don't, like if you're confused when to use parentheses and when not to use parentheses, just use them. Because it's not wrong to put the parentheses every time, but it is wrong to leave it off sometimes, as in the first problem of this set. Okay, so the same domain for this guy as well. The domain is all real numbers intersect 4 to infinity, which equals 4 to infinity. So when you're putting in your answer, you would just put in 4 to infinity, and that 4 is included because the domain for something under the radical is greater than or equal to 0.